we're going to graph exponential decay graphs the same exact way we graphed exponential growth graphs in the previous video. So if you need some help with the details like finding domain, range, and asymptote, maybe go back and watch that previous video. This one I'm going to go through a little bit quicker because in theory we already have some of these ideas figured out. So remember, I want to identify A and B first. I know both of these are decay graphs because the B value is a number less than 1 but bigger than 0. It doesn't matter what the A value is. The B value is going to determine whether we're growth or decay. Both of these are less than 1. So I'm going to plot 2 points. One way to do them is to do that 0, A trick. And then 1, A times B, well, 2 times a fourth is 1/2. Or what I would recommend doing is just use the table on your calculator to find some points. So you could actually find some that aren't fractions, like if you don't want to deal with that 1, 1/2, find some points that aren't fractions using your table. I'm going to plot those 2 points because I said I wanted 2 points. So 0, 2 is right there. And then 1, 1/2 is right about there. Well, this is, as I expected, the points sort of decrease because we said this was going to represent exponential decay. Well, that asymptote is the third thing we're going to draw in there, so that dashed line that the graph gets really, really close to but never touches is still going to be at the x-axis at the line at the equation y equals 0. Since we have not shifted this graph up or down yet, we'll take a look at that in the next video. We know it's not going to make a line. We know it's going to be a graph that kind of starts really high and curves through those 2 points, oops, a little bit better than I did, and then kind of flattens out. Never gets completely flat, never touches that asymptote, but gets pretty close to being flat. So there's my exponential decay graph. Just like last time, I also want to state the domain, the range, and the asymptote. As we said in the last video, the domain for exponential growth or decay is always all reals. The exponent, the x, can be anything we want it to be. The equation of the asymptote, unless we shift it, will be y is equal to 0. Make sure you got the y and that equal sign in there. And then our range is all the numbers that are greater than 0. The graph goes up forever, but it definitely does not go downwards forever. It stops at that 0 and never quite gets there completely. So there's going to be my domain, range, and asymptote. We could graph this second one the same way. I don't really want to graph this one since we've graphed a bunch of these now between this and the last video. But there is one thing I want to talk about with this example. I've drawn in the asymptote. Actually, I'm going to go ahead and just start labeling a couple things. As we just said, domain is always all reals for all exponential growth or decay graphs. My asymptote is still the equation y equals 0. It's that horizontal line. But something interesting happens with the range this time. And if you look at the equation, you should see something that's very different than what we've seen before with some of these examples, and that's that our A value is negative. Well, if you remember what negative A values did in previous problems, they do the same thing, or previous equations, they do the same thing with these exponential growth or decay graphs. They flip them. So they no longer face the same way. They're flipped over the x-axis. And so just making a really rough sketch of this, if I imagine taking that first graph and flipping it upside down, it's going to look something like this. It's probably very off of what it's supposed to look like. But I just want to get a rough idea. The reason then that our range has changed, remember our range tells us how high or how low the graph goes. This time the graph doesn't go upwards forever, it goes downwards forever. So it's still going to be y and it's still going to be 0, but this time it's not all the numbers bigger than 0, it's all the numbers that are less than 0, because my graph starts from 0 and then drops down from there. So just watch out for negative A values. They're going to change your range around ever so slightly, just so it's less than instead of greater than. But notice it still doesn't touch that asymptote. The range is still going to be just less than, not less than or equal to.